Hey everyone, welcome to the ninth episode of the Coffee with Cosmos DB series. I hope you liked the announcements about Cosmos DB at Build yesterday. If you have missed those, you can always go back and capture those in the book of news. With that, coming back to this series, if you have missed to join the previous session, you can watch the recording, which is available in the Cosmos DB series if you go to the playlist. If you will, if you would like to know more about a particular topic or a session, please ask in the chat, and we will take it up and discuss here. If you're joining this live session for the first time, it's this series is all about spreading the knowledge on Cosmos DB by the experts to the community. So please make sure to subscribe the channel and share with the community who are looking to learn more about Cosmos DB or in general databases. If you're interested to present or have any feedback, reach out to me. And thanks for all the feedback so far. With that, we have a guest today. I will go ahead and introduce. We have another PM joining from the Cosmos DB team today. I will add him to the stage. Hey Shriram, how are you?
Hi Suji, I'm doing good. How are you?
Yeah, doing well. Why don't you introduce yourself to the audience?
Okay. So my name is Shriram, and I'm part of the product group in the Cosmos DB pillar, specifically focusing on Azure database for Postgres. And my role in that particular team is to build migration tools which are easy to use and consume and pave off the burden to migrate into Azure database for Postgres. And this is the topic that I'll be focusing on today. So happy to
Got
be
it.
here.
Yeah, I think it's going to be a full-fledged demo based, and I won't be interacting like the way I do in other sessions. So the stage is yours. I mean, you can take it forward.
Okay.
Yeah,
All right.
and yeah,
Go ahead.
just to add one thing, if you have any questions who are watching this session, please feel free to add those questions in the chat. I will take it up with Sriram at the end of this session. Yep, go ahead, Sriram. Thanks.
Right. Thanks, Suji. So for those who are not familiar with Azure Database for Postgres, basically what it means is it's a Postgres offering as a platform as a service. And we have introduced multiple flavors over the past years. We started with something what is called a single server, which is Postgres running on a Windows machine. And we recently announced the deprecation or the retirement of that. And we are moving forward with a more high performant Linux based offering for Postgres, which is called the flexible server. And this is our go-to PaaS offering in terms of Postgres in Azure. And for those customers who want like IoT-based devices or who want a hyperscale service, we also have the Cosmos DB for PG. Now, having said this, it's great that we have a great Postgres as a service, but it wouldn't be that great if we don't have a path to migrate into that particular PaaS offering. There are customers who can spin off and build native apps on this PaaS service, but more importantly, we have a huge fleet of customers who run their Postgres on their on-prem data centers, who run their Postgres on their own IaaS or infrastructure as a service in VMs, and also other competing cloud services as well. So how can we make them migrate their workloads to Azure Database for Postgres? So that is the topic that we want to do. And I want to cover two specific areas, like what are the ways that you can actually do the migration, and what are the existing toolkits that the customer can use as it is today to perform this migration. Okay, so let's get started on this. So
Sure.
there are basically two ways in which you can perform a migration from a source Postgres server, irrespective of where it is hosted, to a target server, irrespective of where the host is. Now, it can be done through two modes. One is called the offline mode of migration, and the other one is called the online mode. Now, offline mode, what does it actually mean? It basically means that we are going to take a snapshot of the databases at a particular point in time. We take the snapshot and we try to restore it in the target server. Very simple, right? Like no complications, and it basically is the most simplest way to go ahead and do the migration, right? But if you look at the downside of these things, in general, as a rule of thumb for performing offline migrations, what we would want is any application, or be there might be many multiple applications that writes data into these target server in this database, right? We would want all the applications to be stopped before we take the snapshot, And then once we restore it into the target server, we want to make sure that the target is exact copy of the source and then point your applications to the target server, right? Now, if you think about this, the downside of this is going to incur some downtime because we want all the applications to stop any transactions that are happening at the source, right? So, though it is very simplistic, this might be a hindrance or this might cause some disruption to the applications that are writing to it. So, it might require some downtime. But if the database sizes are small, the ideal way and the rule of thumb that we recommend to the customers is to go ahead, simply take some downtime and get done with this migration in a faster way and without going into the complexities of online migration. Now, so let me get started with this and show you a demo as to how we can perform this offline migration. Okay, so
That would be cool. Yeah.
yeah, let me share my screen here. Are you able to see my screen with the two
Yep.
command prompts? Okay. So the left is basically I've connected to a source server and I've created and I've loaded a simple database here called SampleDB. And it's very simplistic because the goal is to show some demo that can complete within the stipulated time that we have here. Right. So I've created a very simplistic database and I've created one table inside this. And if you look here, the number of records is also very small. So it's 300 records that we have on the source. And on the right is my target server, which I want, which is the Azure database for Postgres flexible server. And I basically want to copy this database, the 300 records in a single table to this flexible server. And let's see how we can do that. Okay, so there is this tool called PG dump and restore, which is the vanilla dump and restore that you get with an installation of Postgres. Let me exit out of the target of my source server here and let me copy this command as to how to take the dump. And I'll walk you through the parameters of the dump in detail. Okay, so now I have installed Postgres in my laptop and it comes with the PG dump and restore automatically. So these binaries are installed automatically. Now, if you look at this command, PG dump, what does it do? It's basically asking for a host name to which it needs to connect to. So in this case, my source is running in a VM in Azure. So I've given the host name. And basically, on behalf of which user should I perform the dump? And I've given that particular username and what is the database for which I want to take the dump. And you can read the PG dump documentation. There are multiple options that you can use with this dump command. You can, for example, omit the data and just take the schema. You can perform the dump of all the databases inside a server at the same time. And there are multiple options, but for now, we're just interested to take the dump of this schema for this particular sample database and try to restore it in the target. And where is the dump file going to go ahead? It's going to go into my local system under this particular folder path. So let me go ahead and execute this. And this will ask for the password. And once I give the password, all the statements. So here we are not specifying only schema only or the data. So this is going to comprise of all the DDL statements that would involve creating the table structures and also copying the data, whatever is there from the source server as a part of the dump file. So now it's inside my documents and as a part of this file. So let's go and see what is there in this file. I'm going to open it in Notepad here. So as you can see, it has a bunch of set statements, and then there is this create table, which creates the table structure. There are some alter commands, there is some sequence, and there is also this copy command, which copies all the 300 records as a part of the SQL file. Now, what we want to do is we want to go and restore this in the target server. And before we do that, we haven't created any database in the target, right? So we have to create a database. So let's create a database called the same sample DB in my target server. So the database is done. And let me do the restore of this particular file into the target. And I'll walk you through the command and go through it in detail as well. Now, if you look at the command, we are actually using another binary called pSQL. So again, this also comes with the installation of Postgres. And if you look at it, like what is the parameters it takes, it basically asks for the host name. And the restore has to be done by a particular user. So give me the username and the password for that particular user. And under which DB should I want to restore or replay every single statement that we saw in the SQL file? Under which particular DB should I go and do it? We just now created the sample DB, so that's what we are passing here. And let's go and execute this. So it's going to prompt me for the password. And once that is done, you should see the runtime output saying that there are some statements that are being executed. The create statement got executed. There was some sequence that got created. And we also copied the value of 300 records to the target. Now let's go ahead to the target and verify if this got created and if this restore was successful. Okay, we are now connected to the target DB. Let's just issue a count star and see if the row count match. So we had 300 rows in the source, and now we are able to see 300 in the target. So we were able to do a very simple dump and restore of a particular database from a source Postgres server to the target Postgres server. In this case, it happens to be Azure database for Postgres. So this was a very simple example of a dump and restore using the PG dump and restore. Now, as I said before, there are imagine, so this is just a very simple database with very simple, not even touching the tip of the iceberg of the actual production database that is being run by multiple customers, right? Like if you look at the Postgres customers that we have, these are like multiple retail banking industries which have like who have like really complicated database, and the size of the database can also be very huge. We are looking like in terms of terabytes and whatnot. Now, if they go and take this approach of doing a PG dump and restore, the dump itself, based on how the data is distributed among their tables and whatnot, the dump itself can run for a very long time. We are looking like probably for 1 terabyte, we have seen cases where the dump takes more than 15 hours. And similarly, a restore has to be performed by replaying each and every SQL statement that we got as a part of the dump file into the target. So we are looking at a very like it's going to take a really long time for this dump and restore to complete. So what are the alternatives to this? Like many customers, especially banking and other mission critical applications, might not be open to take such a huge downtime. So what are the alternatives for that? So there are multiple ways to address that problem. So instead of taking the PG dump and restore route for doing the offline migration, there are other good open source tools which can perform the dump and restore in a very faster way. So rather than taking a dump and putting it locally in a file, we have a thing called PG CopyDB, which is an open source migration library that can actually stream the data from source to target. And we have seen much better performance when it compares to the native dump and restore. So that is one. And for other customers who have some really strict restrictions in terms of downtime, we can go for the online migration. And I'm going to walk you through like what an online migration is and going to do a quick demo of the same. Okay.
Okay. Okay.
So online migration. So what is the difference between online and
Before that,
offline?
there's a question.
Mhm.
Uh, Let me highlight that as well. So if you want to verify whether indexes were copied correctly, how we can
Mhm.
do this?
So we have a script which can actually so again, this is not published. This is something in my GitHub repo, which basically goes and takes account of the database objects in your source and target, and if there are any missing indexes or if there are any sequences or anything, any database object that are not getting copied, that will be able to identify that. So for now, I have not captured that in this demo because I want to keep this demo simple and
Got it.
I wanted to complete it within the given time. So that's the main reason. And I
Sure.
can share that link to the GitHub repo as well, post this call. Any other questions before I move on to online migration?
I think adding to that, there was a general question in general, how do we verify the migration happened correctly? I hope you answered that. So you have the object script file where you can check the
Yeah,
objects. Okay,
right, right.
got it. Yeah, that's the
Um,
only question I see. You can proceed.
okay, okay. So now what's the difference between online migration and offline migration? So offline migration, as I told before, um, as a general rule of thumb, like you have to stop all the applications that are writing to your database before you take the snapshot and you do a restore. Now, if you do not do that, and if there are still transactions that are happening, then there is going to be some data difference between the source and target server, target database, right? Now, this can be addressed in the online migration. So, what online migration is, we are not asking applications to stop the transactions on the source database, but rather the application can still be writing, can still be reading, no problem. But when we do the migration, what happens is we try to take the snapshot, we try to restore it, and once the restore is complete, all the transactions that happened on your source will be replayed in that sequential manner in the target server as well. So this is what we call it as replication. So the dump and restore will be followed by the replication, and once the target is an exact copy of the source, the customer can go and perform a cutover. And cutover is simply telling this migration activity, hey, stop the replication. We have validated that the source and target are an exact match, and you can stop the replication. And now the customer can point the connection strings to the target. Now, what is the benefit of doing that? Is this? It's going to lead to a very, very minimal downtime for the application. So it's not that we are looking at multiple hours or days for a big database to go and complete the migration, but rather we are looking at a very minimalistic downtime, where from the point where you stop the application, perform the cutover, and then point the applications to the target server. So the downtime is going to be very minimal for online migration when it compared to offline migration. Now, what is the downside of it? Um, Online migration for Postgres, it comes with its own set of limitations. And for example, let me point out two important limitations that are very common. So for example, every table that's involved in this migration should have a primary key. Let me tell you the reason for that. So for example, let's say there is an update statement that happened while we carry out this migration. We have to identify which particular row got impacted and perform the same update in that particular target cell. If there is no such primary key which can uniquely identify that row, the replication will not be able to identify which particular row got impacted. So that is one such limitations. And the other one is let's say there is a new DDL change that comes up, or let's say the schema has changed of the table while you're performing the migration. Those will not be able to be replicated in the target. And the reason is these are the restrictions that comes with the Postgres engine. It's not related to any particular tool, so to speak. So you can take any tool in the market, like most of them will still follow the replication provided by the Postgres engine, and all these replication things will still be applicable. So that is where like online migration gets is a really tough one to pull off, because we won't be able to identify like what are the transactions that are happening. Will that be supported? Will this be a limitation? Can this break the entire migration? So that's why we say like only unless and until there are very strict downtime requirements, go ahead with offline migrations. It's easy to execute, and there is no restriction in terms of the size and what. It's just going to take a longer downtime. But online migrations, there are some known restrictions in terms of the Postgres engine. Now, the next part of the demo, what I'm going to do is I'm going to show you a tool, the first party tool built by Microsoft called Azure Database Migration Service, or DMS. And we'll see how we can perform online migration using the same. And in fact, we want to do the same database, the sample DB that we have, from the same source to the same target. But in this time, we are going to have some transactions that are happening on the source, and let's see how DMS is going to handle that. That's the second demo. Okay.
Cool.
So let
I guess
me,
there was another question, but I think you already
okay.
answered, like in terms of when using the
Okay.
PostgreSQL.
Okay, great. So I'm just going to drop this database and start from scratch. Okay. Let me. Okay, so database is dropped. Okay, database is done. So now let me go ahead and okay. Before we get into the DMS portion, there are a few things that DMS needs before we can actually use it for the data migration. Now, DMS, you can think of it as like it's a data movement tool from a source server to a target server. Before you can use the DMS, you have to perform the schema migration, meaning whatever schema is there in your source, you do and copy it in the target, and then you can actually use DMS to do a fast migration, data migration from the source to target. Okay, so we are going to take the schema of my source and let's see what are the commands that are needed here. And I'll just walk you through these commands in detail as well. So if you look here, again, we are using the pgdump command, and there are a few things that get added to this particular command. One is we are using a particular option called -s, and -s means just take the schema, do not include the data as a part of the schema dump. Okay, and then there is this thing called -x. And what is this option? This means that we are not going to involve any grant statements, any ownership statements as a part of the schema here. And why we do that is like probably the roles and the users that gets created might not even be present in the target while we perform this migration. Maybe the customer might have planned to do it after the schema and data migration is complete, right? So if this is there, if the grant statements are there, then it might lead to unwanted runtime errors, which is not necessary in order to do the data and schema migration. So let me go and execute this and show you the content of the file. And so now if you take a look at the sample db.schema, it will be generated, it will just have the DDL statements. It will not have any copy. It will not have any DML statements like inserts. Um, so it's just going to be the DDL or the schema migration. Let's go and look at it. And if you look here, again, it just has the alter table, create table statements, and there is no grant statements, there is no copy command, there is no insert statements, nothing, right? Now, let us go and restore this schema in the target. Now, again, before doing the restore, the basic step is to create the database. We remove the data, we drop the database. So now let's go and create it. Okay, so we created it. Now let's restore the schema onto the target. We are going to use this. Restore command is same as the other one. The previous one we did for offline migration. It's going to ask for the host on behalf of which user should I restore it, and what is this file. So in this case, we are just going to do the schema restore. So we are going to use this file, and the schema restore will begin. Okay, so now there is no copy command, so we just will be having the schema. So let's verify if the schema is there or not. Okay, so we are connected, and if I run select count of star, it should identify that there is a table called employee that got created, but ideally there should be no records, which is the counter C. So we can confirm that, okay, the schema is intact now. Now let's try to begin the data migration. So for data migration, as I said, we are going to go to the portal, Azure portal, and we have to create a resource called Azure Database Migration Service. It's very similar to creating any other Azure resource. Let's say you had the experience to create a virtual machine or any service, so to speak. It just asks for the subscription, resource group, the region in which you want to deploy it. And one important thing to call out is it's free of cost. There is no cost for using the database migration service, and in the interest of time, I already created one. Now, this DMS will also allow cross-region migrations, meaning like irrespective of where your source server is hosted, which region it is, as long as the DMS is able to connect to your source and target, the migration will work seamlessly. But in general, as a rule of thumb, you have to avoid as much as possible cross-region migration because it's just going to take a longer time for the migration to complete since the data is moving across regions. And in this case, I've already created a DMS resource, and I'm going to create a new project. So let me give a name for this project, say DMS demo. I'm going to do a name validation. In this case, my source is a Postgres, and my target is also Azure Database for Postgres, and I want to create an online migration. So let's go ahead and run the activity. And activity is basically give me a pair of source and target for which I need to go ahead and start the data migration. Okay, so in this case, let's provide them the host name of my source server. Just going to copy this, and this is my username, and I'm going to give the password. Now, basically, what DMS is, it's a middleman. Now it's trying to connect to the source. So in this tab, if there is any problem with connect to the source, it just errors out and say, hey, I'm not able to connect to the source. The data migration cannot happen. Now this is able to connect to the source successfully. Now let's go and pick the flexible server for which we need to migrate the data. So this is the flexible server, and it's asked for the password for the username. And then if the connection is successful to the target, it will go to the next tab of picking the databases. And if you look at that particular tab, the select databases, what it's basically going to do is it's going to scan through the list of databases in your source, and similarly scan through the list of databases in the target. And if there is a name which is exactly matching the name of the source and target, it will potentially show you, hey, I've found that these are the databases which are there in source and target. And do you want me to conduct the data migration for all these databases? Or you can actually pick the list of databases that you want to. So in this case, we are more focused on the sample DB as a part of this migration, right? So I don't want to include everything else, but rather I want to just include sample DB as a part of my migration. Now the next thing here is, okay, now the sample DB is what we want to migrate. And then basically it's going to look for, okay, does all the tables and other database objects that gets as a part of this source server, does it have an exact mapping of the schema in the target? And it is able to identify, okay, like I've identified this one particular entity called employee, and there is an exact match for that in the target schema. And why is because we completed the schema migration correctly, and it was able to identify that, yeah, the schema matches for employee in the source and target, so I can move the data for this particular table. And if there are multiple tables, you might even select like what is the table that you want to. You can even, there is granularity in the amount in the list of tables that you want to migrate as well. So I'm going to pick employee here. And in this case, like it's going to ask for like, hey, how many number of tables do you want to load in parallel? Ideally, this is constrained to the compute of the DMS that we configure. So even if you increase beyond 4 or beyond 5, that's not going to be any impact because behind the scenes, we provision a DMS with 4V code. So in fact, going forward, we are even trying to remove this tab as a part of the DMS experience. And then finally, we just create a name for this particular activity. So I'm just going to give demo activity, and I'm going to start my migration. So, okay. So the migration will begin. And in the meantime, let's go back here, connect to the source, and let's try to insert some data. Okay. Okay, so now I'm the source. So if I look at my current data here, there are 300. And let's see where the migration activity is. So you can do a refresh to see where exactly is the activity here. Um, so if I just did a refresh and it says like, hey, I've completed the dump and restore. It's ready to do a cutover. And I can even click on the database name and it can show you the details like, hey, how many tables were involved in this? And what is the state of the particular table? Is it queued? Is it loading? Is it completely loaded? So it says it's completely loaded here. Let's go and verify that as well. So in my target, let's do account. So before it was 0 and now the base copy has completed. Okay, so now it's completely loaded, which is fine. Now let's do one thing. Let's try to insert like few hundred records on my source. Okay, so 100 rows got inserted. So now if I do a count start, the count should be 400. And remember, we are still keeping this migration running. We have not performed the cutover. Ideally, the inserts that happened should be replicated to the target. And ideally, how the replication happens is like there will be a replication slot. We use a concept called logical decoding of Postgres, where we create a replication slot on the source for a particular database. So all transactions that happen will be logged as a log file, and we will read that log file and we will convert it into a Postgres equivalent query and we'll try to replay it in the target, right? So this is the thing that happens behind the scenes. And you can see that the DMS was able to identify that there were 100 incremental inserts that happened, and it was able to apply all those 100 changes to the target as well. So now let's go and verify that. If I run this, now the count is coming as 400. So it is not just doing a base copy, but rather it is also trying to replicate any changes that happen at the source. It will be able to do and replicate it in the target. So the DMS was able to do it successfully. So this is an example of how online migration can be done for Postgres source and target servers. You can use Azure Database Migration Service. And then if you can confirm, okay, now I don't have any transactions, I can pick a time where I want to stop the replication because I'm confident now that the target is an exact copy of the source. Now I can go and trigger a cutover. And basically cutover, what happens behind the scenes is if like, while trying to do a restore, we remove all the constraints so that like it completes in a very fast way. The restore completes in a very fast way. And as a part of the cutover, we'll stop the replication and we'll re-enable automatically all the constraints like foreign keys and triggers will automatically enable in the target server, right? So now I've completed the cutover and then I go here and when I do a refresh, you can see that status is completed and all the changes were applied. Okay, so this was the demo for online using Azure Database Migration Service. Now, to come back, like is DMS a perfect tool? It seems everything seems to be working. As I said, um, there are some restrictions for online migration to work for Postgres, and it's not limited to DMS or any particular tool, so to speak. These are restrictions in the PG engine. And even for DMS, like we have seen the error rates to be on the higher side as we scale up with the size. So for more than 1 terabytes, the dump and restore is going to take a long time. The lag would have accumulated. So we are seeing like as we scale with the size of the database, we are seeing higher error rates. So going forward, we are trying to completely revamp the entire migration infrastructure for DMS and try to make it more scalable to handle database of any size and no any restrictions in terms of the size or the number of database objects it can handle. So that's a work in progress, and we are trying to revamp and ship a new version of DMS this year to handle migrations in a more scalable and durable way. So that's something that I wanted to share as well. So that's pretty much it, Sadi, in terms of
Yeah.
demo.
Thanks, Shriram. I think it was a great demo that you demonstrated, like using the two scenarios. Yeah, it's always good to see the live demos, right, working. And thanks a lot for all the insights and also sharing the journey of through the Azure
Mhm.
portal. Before I close, I would like to, yeah, see if there are any questions. Yeah, I don't see any other new questions. Those were the two questions that we had. But I have one question in terms of the time you mentioned, right? I think since it's a 300 rows data, it took like two
Mm,
minutes.
right.
Is there a benchmarking that we have, like to see, okay, for 1 terabyte, how much time it take,
Yeah.
or does it depend on different factors?
Yeah, it does depend on different factors, I would say.
Okay.
It also depends on how your data is distributed among inside a database. Like, is it
Mm-hmm.
like skewed to one particular table? Because like
Okay.
the copy and restore of of a table in DMS is single threaded. So if you have like 1 terabyte data in one table, then the process is going to run forever, right? So
Got
that's
it.
where we are even adding logic to partition a bigger table and try to move it in parallel. So these are the
Mm.
enhancements that are coming in the next version of DMS.
Got it.
That
Okay.
should be.
Thanks.
Yeah.
Do you have a link that contains the roadmap, or is it just a GitHub repo that we have? I think it's open source, right?
I can share it. I need to ask like the
Okay.
team for that particular thing, and then I can share it with
Oh,
you.
all right. Thanks. Okay. Yeah, I think that's all we had for today. I know that we are running out of time. Before I close, those who are watching, please make sure to subscribe the channel. And if you have any feedback, please share with us. We will meet again in a couple of weeks. Next week, I think next time we will be talking about an interesting topic about query patterns with Azure Cosmos DB NoSQL API. Make sure to join. Yep. Have a good week ahead. Thanks, Sriram. Thanks,
Thank
everyone.
you.